Hello, here is today's lesson. We are going to factor and solve with the zero product property. You may want to look at these problems, do them on your own, and then look over the answers from today's lecture. Here's your do now. 4 problems, sorting the terms of these polynomials. 2 more questions. 8 problems reviewing factoring, and 2 word problems. For the enriched portion of today's lesson, we are going to study this word problem for a flare or any projectile. I'm going to start working through these problems now. So for the first one, what I'm going to do now, we're arranging the terms of each polynomial so that the powers of x are in decreasing order. So that's from big going down to small. Alright, so with this one, we look at the powers. There's 3, 2, this thing has a power of 1, this thing also has a hidden power of 1. So for the first one, 4x cubed is the first term, x squared is the next term, x is the next term, and 2. If you want to think about this way, 2 can be rewritten like this, where 0, right, anything with 0 power is 1, so it has no x term, so it goes at the very end. We can go through this praxis again, add it in, make it super obvious. Now we can see we just need to switch these two. X squared plus, minus 3x plus 4. That's the answer to the second do now problem. Here, go through similar exercise, add in the exponents, another swap, 3x cubed. Notice we have no x squared terms. So then the next term is this one, plus 4. Last do now for the sorting. X to the fourth is going to go first. X squared next, minus 1. Okay, so like yesterday's discussion questions, what must be true about A and B? We remember that squaring just means multiplying it by itself, so we can rewrite it like so. Equals 0. And we notice there's no repeats, or it is repeated, but these two things are the same exact thing. So when we solve for 0 here, we don't have to do it twice like we did yesterday, like this. That's what I mean by it's repeated. So we just need to solve it once. As we take away b from both sides. What must we know is true about A and B? They are opposites of each other. They are opposites. For the second discussion question, it's very similar, but now notice the minus and plus difference. So when a minus b squared equals 0, what must be true about A and B? We can go through a similar procedure, reminding ourselves what squared means. Solve this equation now, which means we add b to both sides. These go away, giving us A equals B. They are the same. So now if we can identify patterns look like this, we know that the answers must be the same, and up here we know that for this kind of pattern, where we have a plus b squared, we know that they must be opposites. That's going to come in handy for like these first two problems. Okay, then for these ones, 169, I think that's 13 squared. So for this first one, maybe we'll go through the exercise, remind ourselves how to factor using the box named diamond. Draw your box. Put your squared term and your constant, or your third term, in decreasing variable exponent order. Draw your diamond. Here we have the diagonal, which is 169 times a squared. And this one is your middle term, or your a term. In this case, we don't have any. It looks like this. We think about, okay, these ones have to be opposites, because this problem, right, whatever this other multiplier it is, they have to be opposites, because that's like this first rule we went over, right? Oh, not opposites. No, they're opposites. Yes. So you will see that they are opposites. So we think about two numbers that add up to 0 but multiply to negative 169a squared. This one does end up being a perfect square, which means the missing number here is 13. 13a, positive 13a, negative 13, positive 13. This one looks like a minus 13 times a plus 13 equals 0. As we solve, now that we factored it, okay, that was step 1, factor. That's like the stuff from yesterday. We solve something here and here. A minus 13 equals 0. So a has to equal positive 13. This one, a plus 13 equals 0. So a equals negative 13. And there's our answer. Maybe in or darker orange. So we can check our work along the side. So 13 squared minus 169 equals 0. Is that true? 169 minus 169 equals 0. Yes. Check. Notice we also have to check the negative version. And that ends up being the same. Oops. Second problem. Y squared minus 144, a similar setup. Or we can take some shortcuts and notice that that's a perfect square too. So this is known as difference of squares. So you can probably see that 1a and 1b are very much similar. But for practice sake, we can go through the motions. There's your diamond. 144 cross negative 144y squared, 0y, minus 12y plus 12y, minus 12y plus 12y, y plus 12, y minus 12, plus 12. We've factored it now. And we solve. Okay, and since I'm running out of space, we see that y equals positive 12 or negative 12. We're going to skip the checking. For these two problems, it's a little bit more complicated. So when you see for 2a, you see that they have fractions here. So maybe in the first step, you can get rid of those. So we're going to multiply both sides by 5. So when we do that, it looks like 5 Okay, it froze up for a bit. Start that again. Looks like so. It's not showing up.